I want to start today's deep dive with a bit of well, it's kind of a domestic scene, actually, because it's just too good to ignore.
Oh, I love a good historical domestic scene.
Right. So picture this. It's 1953. Francis Crick, yes, that Francis Crick comes bursting through the front door of his house.
Just vibrating with energy, I imagine.
Exactly. He is absolutely vibrating. He finds his wife Odile and tells her, practically shouting, that he and his colleague have done it. They have discovered the quote-unquote secret of life.
Which, is a fairly bold claim to make before you've even had a cup of tea.
I mean, right. But Odile's reaction is actually the best part of this whole story. She barely even looks up.
Just totally unfazed.
Completely.
Yeah.
She essentially dismisses him because apparently Francis was always coming home and saying these grand manic things like, oh, Francis found the secret of life again. That's nice, dear.
That's hilarious.
Yeah.
But as history shows this time, he really wasn't exaggerating.
No, he wasn't, because he and James Watson had just identified the double helix structure of DNA.
And, in doing so, they didn't just find a chemical structure. They found something that would fundamentally change the entire philosophy of biology.
Yeah.
They discovered that at the very center of life, floating right there in the nucleus of the cell, there isn't just chemistry, there is information.
And that distinction, that gap between raw chemistry and actual information is exactly what we are unpacking for you today. We are doing a deep dive into the origin of biological information.
It's a massive topic.
It really is. And we've got a pretty substantial stack of source material here, primarily drawing from interviews with the philosopher of science, Dr. Stephen C. Meyer, and some really fascinating excerpts from The Case for a Creator.
And I think we should clarify the mission for this deep dive because it's really specific. We aren't just looking at how DNA works mechanically. We all kind of learned that in high school.
Right, the basic biology.
Exactly. Instead, we are looking at the argument presented in these sources that the massive amount of digital code found in DNA points away from naturalistic processes.
Things like random chance or chemical attraction.
Right. And instead points directly toward an intelligent cause.
So for everyone listening, we are going from the library inside your very cells all the way to the Cambrian explosion. And we're going to ask the big question posited by these sources. Is life a happy accident, or is it engineered?
To really understand the stakes here, I think we first have to grasp the sheer density of the information we're talking about.
Yes, set the scale for us.
Because people hear DNA is complex, and they nod, but they don't really visualize it. When Dr. Meyer and others say DNA contains information, they mean it is literally a 4-character digital code.
ACGNT.
Precisely. Those chemical bases function exactly like letters in an alphabet, or maybe more accurately, like binary code in a computer system.
Yeah.
And the amount of data stored in there is just mind-boggling.
Like, how much are we talking about?
Well, the source material makes this comparison.
Ah.
Human DNA contains more organized information than the Encyclopedia Britannica.
Which, for anyone who didn't grow up with a massive shelf full of those heavy leather-bound books, was essentially the internet before the internet.
Oh yeah, 30 volumes of dense, tiny text.
So much text.
Now perform a quick thought experiment. Imagine if we received a radio signal from space. We tune our satellite dishes, and when we decode the signal, it wasn't just static.
Okay.
It actually contained the code for the entire Encyclopedia Britannica, first volume to the last.
I mean, we'd be throwing a parade. We would immediately say aliens exist. We have definitive proof.
Exactly. We would immediately assume an intelligence was behind it. There is no natural phenomena, no wind, no erosion, no lightning storm that spontaneously writes encyclopedias.
Obviously not.
But, and here's the crux of the argument Dr. Meyer presents, when we find that exact same level of specific information-rich code inside a living cell, the standard scientific assumption has always been that it's the result of random, unguided natural forces.
It does seem like a bit of a double standard when you frame it that way. I mean, if code implies a coder in space, why doesn't it imply a coder in biology?
That is the exact question the sources are raising.
And speaking of data density, there was one fact in the notes that actually made me stop and reread it like 3 times. The teaspoon fact.
Ah, yes, the teaspoon fact. This comes from the geneticist Michael Denton. It's a brilliant way to visualize just how efficient DNA storage is compared to our absolute best human technology.
He estimated that the information needed to build the proteins for all species that have ever lived.
Every single one.
Right, like every plant, every amoeba, every dinosaur, and every human could fit inside a single teaspoon.
And here's the real kicker. There would still be room left over in that teaspoon for the information contained in every single book ever written by humanity.
In 1 teaspoon.
It's almost impossible to conceptualize.
That is an efficiency level that makes Silicon Valley look like they're chiseling on stone tablets.
It really does. And this is exactly why Bill Gates himself went on record saying DNA is like a software program, only much more complex than anything we've ever devised.
I really like that comparison because, we get software, we understand how code works. But I also feel like there's a bit of a logical trap in that analogy, isn't there? Because software isn't a natural occurrence.
There is a massive logical implication there, and Dr. Meyer points it out brilliantly. If you look at software, say, the code running the banking app on your phone, you know fundamentally that it didn't write itself.
Right. A windstorm didn't just blow through a server farm and accidentally assemble the code from Microsoft Excel.
Exactly. Code always implies a coder. A program always implies a programmer.
So that is the heart of this DNA to design argument. If biological information functions exactly like code, we need to ask who or what wrote it.
Right.
But before we jump straight to design, we have to do what good scientists do right. We have to look at the other possibilities.
We have to rule out the alternatives.
Yeah, this is the Sherlock Holmes part of the deep dives. We have to rule out the usual suspects. And the first suspect is the one I think most of us learned about in high school biology, the classic prebiotic soup.
Right, the famous Upper and Haldane hypothesis. The idea that billions of years ago, the Earth was this warm, nutrient-rich chemical broth. Lightning struck, or maybe UV rays hit it, and poof, life eventually emerged.
It's a great image. It feels very plausible. I mean, we've all seen those diagrams in textbooks for decades. But our sources suggest this soup might actually be a total myth.
The geological evidence is surprisingly shaky. You see, if this highly concentrated soup existed for millions of years, it should have left a massive geological mark. Specifically, we should be able to find nitrogen-rich minerals in the oldest sedimentary rocks.
Why nitrogen specifically?
Because amino acids, which are the building blocks of life, are extremely rich in nitrogen. If there was a global ocean full of amino acids, that nitrogen would have inevitably settled into the rocks over time. It's a chemical signature that absolutely should be there.
Okay, so the obvious question is, when we check those ancient rocks, what do we find?
When geologists look at the early geological record, no nitrogen deposits.
None at all.
None that support the theory. It's almost as if the soup never actually existed.
So the pantry was basically empty. But wait, what about those famous experiments, the Stanley Miller experiments where they zapped gases with electricity and created amino acids in a little glass flask?
Right.
That was hailed as definitive proof that you can get life from non-life.
That is the textbook success story.
Right.
But when you look deeper, there are two huge glaring problems with that experiment. First, the mixture of gases Miller used, methane, ammonia, hydrogen, is now widely believed by geochemists to be the completely wrong atmosphere for the early Earth.
Oh, really?
Yeah, he used what's called a reducing atmosphere, which is very friendly to generating chemistry. But the early Earth likely had a neutral atmosphere composed of things like carbon dioxide and nitrogen.
So he essentially cooked with the wrong ingredients. He rigged the game to get the result he wanted.
Basically, yes. But the second problem is actually even worse. In those experiments, while they did manage to create a few amino acids, the reaction also produced a massive amount of tar-like sludge.
Sludge, like actual tar.
Yes, cross reactions. The chemicals started bonding in ways that would actually destroy any hope of life forming. It's like trying to bake a delicate cake, but your flour and sugar keep turning into cement before you can even mix them.
That sounds problematic.
Very. The source material argues that without an intelligent scientist strictly interfering to extract and protect those fragile amino acids, the soup would just become a toxic dead-end mess.
Wow. Okay, so suspect number one, the prebiotic soup doesn't really have a solid alibi. It barely even exists in the rock record. Let's move to suspect number two. Random chance.
The get lucky theory.
Yeah, the idea that if you just wait long enough and shake the giant bag of chemicals enough times, eventually they will accidentally form a functional protein.
Which reminds me of the infinite monkey theorem.
Oh, right. Give a million monkeys a million typewriters, and eventually one of them accidentally types out Hamlet.
Exactly.
Yeah.
And George Sim Johnson had a great quote about this in our stack of notes. He said, Einstein said God does not play dice. He was right. God plays Scrabble.
I really like that framing. But does the math actually work out for the Scrabble theory? Can you blindly shake your way to a working protein?
The short answer is no. And the long mathematical answer is really, really no. Let's look at the probabilities provided by Dr. Meyer. To get just one functional protein by pure random chance, you need to get the amino acids in the exact correct order.
Because it's not just a pile of beads, right? It's a sentence. The specific order determines the meaning.
Right. And proteins are incredibly complex three-dimensional structures. They have to fold into a very specific lock and key shape to do their job in the cell.
Okay.
To get a protein that is just 150 amino acids long, which is a pretty standard modest size, by chance alone, the odds are calculated at 1 in 10 to the 125th power.
Okay, let's unpack that number for a second. 10 to the 125th power. It sounds big, but how big is it really in practical terms?
To put it in perspective, there are only about 10 to the 80th power elementary particles in the entire known universe. Yes, all the electrons, protons, and neutrons combined.
So the odds of getting one protein by chance are worse than finding one specific blindfolded atom in the entire universe.
Much, much worse. Even if you had the entire multi-billion-year history of the universe to try and you were reacting chemicals at the speed of light, you wouldn't even scratch the surface of those odds. It is, mathematically speaking, a naturalistic miracle. The probability is effectively zero.
Okay, so random chance is definitely out of the running. But wait, what about natural selection? Darwin's really big idea, survival of the fittest. Doesn't that powerful mechanism solve the probability problem?
This is where it gets really interesting and frankly where a lot of people get completely tripped up. Natural selection is incredibly powerful once life already exists.
Yeah.
But we are talking about the origin of life itself.
Ah, I see the distinction there. You can't evolve if you aren't alive yet.
Exactly. Natural selection depends fundamentally on reproduction. You need an organism that can copy itself. If it has a beneficial mutation, it survives and passes it on. But to have reproduction at all, you need DNA and proteins already fully working.
Oh man, it's the ultimate chicken and egg scenario. You need the complex machinery to replicate, but you need natural selection to build the machinery in the first place.
It is a massive catch-22. As the famous evolutionary biologist Theodosh Dobzhansky put it, pre-biological, natural selection is a contradiction in terms.
That makes perfect sense.
You basically can't use the ladder of evolution to climb out of the hole if you haven't even built the ladder yet.
Okay, so the soup is a bust chance is mathematically impossible, and natural selection hasn't even arrived at the party yet. That leads us directly to the fourth suspect. And this one is a bit more technical, but I think it's crucial for you to hear. Self-organization.
Right. This is the idea of chemical affinity.
Basically the theory that maybe the chemicals are just like each other. Maybe there is some undiscovered law of physics that makes amino acids naturally line up into a genetic code just because of their physical or magnetic attraction.
Like how magnets naturally stick to your fridge. They just want to be together.
Yeah, that's a great way to picture it.
It is a great analogy,
Yeah.
but it actually ends up proving the exact opposite point. Think about a simple crystal of salt. Sodium and chloride naturally attract each other chemically. NaCl and ACl. They form a beautiful, solid, repetitive pattern.
No.
Exactly. That is order. But it is strictly repetitive. It doesn't carry a complex functional message. It's like reading a book that just says the over and over.
That sounds like a terrible book.
It is a terrible book. But DNA isn't repetitive like a salt crystal.
Yeah.
It features what information theorists call specified complexity.
Specified complexity.
Right. It's highly irregular, just like a written sentence. The quick brown fox jumps over the lazy dog. The letters don't follow a simple repeating chemical pattern. They follow a specific rule of meaning.
And the underlying chemistry of the molecules doesn't explain that irregularity?
No, it doesn't. And here's the real aha moment that Dr. Meyer uses to explain this. Imagine a metal board with those little plastic magnetic letters on it.
Okay, I'm picturing it. The ones from when we were kids.
Yeah. The magnetism, which represents the basic chemistry, perfectly explains why the letters stick to the metal board. But the magnetism does not explain why those letters are arranged to spell the word information.
Right. The magnets didn't arrange themselves into a word. The raw force that holds them to the board has nothing to do with the order they are placed in.
Exactly. The chemistry is merely the medium. It is not the message. The letters themselves are totally interchangeable chemically. An A sticks just as well as a Z.
Because they have the same magnet on the back.
Precisely. There is nothing in the chemical bonds of the DNA letters that forces them to spell out a biological word. And intelligence had to arrange them into a meaningful sequence.
So chemistry explains the glue, but it completely fails to explain the blueprint.
That is it, exactly. And that logic effectively rules out self-organization as the author of the genetic code.
Wow, this is painting a pretty stark picture. All the standard naturalistic doors are closing one by one. But this deep dive doesn't stop at the origin of the very first cell. We actually have to fast forward a few billion years to an event that Dr. Meyer calls the biological Big Bang.
The Cambrian explosion. This is, without a doubt, one of the most significant mysteries in the entire fossil record.
So set the scene for us. When exactly was this, and why is it such a massive deal in paleontology?
It happened about 530 million years ago. And you have to understand, before this specific moment, life on Earth was mostly pretty simple. You had sponges, maybe some very basic worms, and a lot of single-celled organisms.
Pretty quiet oceans.
Very quiet. And then suddenly, in what is basically a geological blink of an eye, we get this massive sudden explosion of highly complex animal life.
When you say blink of an eye in geological terms, what kind of time frame are we actually talking about?
The main window of this explosion is only about 5 million years. Now, I know that sounds like a super long time to us humans, but think of it this way. If the entire multi-billion-year history of the Earth were condensed into a single 24-hour clock, the Cambrian explosion took up just 1 minute.
1 minute out of 24 hours. That is incredibly abrupt. And in that 1 minute, what exactly showed up in the fossil record?
Almost all the major animal body plans we see on Earth today, between 20 and 35 entirely distinct phyla, just appear fully formed. We're talking about complex creatures with brains, advanced eyes, nervous systems, articulated limbs.
Like a trilobite.
Yes, the trilobite is the classic example with its incredibly complex compound eyes. It doesn't slowly evolve in the record, it just suddenly appears.
And this poses a huge problem for Darwinian evolution, right? Because Darwin predicted the exact opposite pattern.
Right. Darwin predicted a bottom-up pattern. Small, slow incremental changes accumulating over vast oceans of time. You start simple, you get a tiny bit more complex than a little more.
The classic tree of life image.
Exactly. But the Cambrian fossil record displays a top-down pattern. The major body plans, the big overarching architecture of these animals, appear entirely first.
It's like looking at the history of human transportation. You don't start with a single lug nut and randomly accidentally evolve a Ferrari over 1,000 years.
That is a perfect analogy.
Yeah.
In human engineering, the primary blueprint always comes first. You decide, I'm building a car, so you lay out a chassis, 4 wheels, and an engine. That is top-down design. The minor variations, like adding cup holders or a sunroof, those come later.
So the fossil record here looks significantly more like intentional engineering than unguided evolution.
That is the core argument Meyer makes. The sudden, rapid infusion of the massive amounts of brand-new biological information needed to build these totally new body plans points heavily to a design idea, not just a random accumulation of genetic accidents.
Right, because to build a trilobite from a sponge, you need gigabytes of brand new genetic code.
Exactly. And as we've already established today, nature struggles mathematically to write even one single functional line of code by chance.
So let's take a breath and recap where we are. We have the mathematical impossibility of the code arising by chance. We have the prebiotic soup lacking physical evidence. And we have the sudden, mysterious appearance of complex animals without clear ancestors. Where does this actually leave us scientifically? The source material leans heavily on a concept called inference to the best explanation.
Yes, this is the standard scientific method used for historical sciences. Because obviously we can't go back in a time machine to actually watch life begin. So scientists use a recognized principle called uniformitarianism for us.
Okay, it is a massive mouthful of a word. Unpack uniformitarianism for us.
It sounds super complex, but it really just means we assume cause and effect relationships work the exact same way today as they did in the distant past. We look at a mystery and ask, what is the sole known cause of information in our current everyday experience?
School books, computer code, hieroglyphics on a wall.
Exactly. And in every single one of those cases, without exception, the source of that specific information is intelligence. It's a mind. We have quite literally never seen a textbook write itself. We have never seen functional software code generate without a human programmer.
So the scientific logic here is if we find an incredibly complex digital code inside the biological cell, and the only known cause of code in the universe is intelligence.
Then the most rational scientific conclusion, though based entirely on our repeated human experience, is that an intelligent agent played a decisive role in the origin of life.
It's not just giving up and saying it's magic.
No, not at all. It is not an argument from ignorance.
Yep.
It's not saying we don't know, so it must be God. It is an argument from what we affirmatively do know. We know exactly what conscious minds do. They generate complex information.
It's like seeing a signature on a painting and just logically knowing there must be a signer.
Yes. The specific 4-character code of DNA is essentially a signature permanently inscribed inside every single one of your cells.
That is a incredibly heavy thought. It really does change how you look at, well, kind of everything.
It shifts the entire paradigm. We so often hear in the media that science and the concept of a creator are locked in a permanent war. But this deep dive investigation suggests that when you really get down to the absolute bedrock of biology, the actual information processing layer, the scientific arrows are strongly pointing away from blind materialism and pointing directly toward a mind.
And that connects so perfectly to the age we live in, doesn't it? We literally call our era the information age. We value data and information as a tangible commodity. We buy it, we sell it, we protect it.
Right. And we know fundamentally that information is completely distinct from the physical matter that carries it. You can write a message in wet ink and chalk on a board, in smoke signals in the sky, or in digital binary. The physical medium changes constantly, but the meaningful message always comes from a conscious mind.
Wow.
Finding that exact same invisible property at the very root of biological life suggests that mind is fundamental to the universe, not just some random accidental byproduct of chemical reactions.
Which leads us to a pretty provocative thought to wrap things up today. A little something for you to mull over after the deep dive ends. If the sophisticated DNA in our cells essentially proves an intelligent design for the physical body, what does that mean for the mind itself?
Oh, that is absolutely the next great frontier of this debate. The source material briefly touches on the human brain. It notes that the brain has neural connections equal in number to the leaves in a 1,000,000 square mile forest.
Which is just, that is impossible to even visualize.
It truly is, and it raises the ultimate question. Does raw biology alone actually explain human consciousness? Does a blind chemical process explain why we feel deep emotions, why we relentlessly seek purpose in our lives?
Or is the very existence of the mind, our unique subjective consciousness, just further unavoidable evidence that there is something far beyond the purely material world?
It makes you wonder. If the hardware is clearly brilliantly designed, maybe the software running in our heads is too.
Exactly. Well, we really want to leave you with that thought today. The next time you happen to look in a mirror, or honestly just look down at your own hand, remember what we talked about. You aren't just a random collection of aimless chemicals. You are a vast walking library. You are quite literally a masterpiece of engineering.
And according to the evidence in our DNA, you might just be assigned original.
It definitely makes you rethink the whole phrase humble beginnings, doesn't it?
Absolutely does.
Well, thank you for joining us on this deep dive into the evidence of biological information. Keep asking the big questions, keep digging into the sources, and we will see you next time.